Yes?
Don't you have to add 50 to it? Subtract 50
Good question. What is it that I computed?
Total change.
I computed the total change. Right? The actual population after 5 days is going to be the original value, 50, plus the change. Right? So yes, you are right. The answer is population in 5 days is the original 50 plus 87.5, and of course we round it to 88, making it 138. Yes?
How are we supposed to get all that summation
Summation notation into this summation?
Yeah.
Oh, let's look at it. Summation notation, well, this notation contains all these symbols on the bottom and the top, right? I, n. Have I ever used number n other than in this notation? No. I do have use of I, right? I shows up there. So, since your explanations are going to be for me, for a human being, right? Then typing something like sum underscore I would be quite enough for me to recognize that you mean summation over index I, and then whatever you want to add, right? You may introduce notation df underscore I for the change of f on the ith interval, and you may want to put it in brackets so that I know what is it that you are taking. So make something human out of those so that you can type quickly. And I would like that to be a short part of your preparation for the test. Your attempt to convert strange standard notations into something typable, right? Limit as delta t equals goes to 0. Oh, it's easy to type lim underscore dt dash dash greater 0. So let me make this typable for you. lim underscore in the brackets dt dash dash greater 0 or 1 dash greater, and you don't need to use any Google formula, any kind of formula. This is ASCII code. Integral. How to type that? Well, int is enough for me to understand that you mean integral, because there is nothing else we use at this point that starts with int. Then underscore 0, and this at 5. I can easily read it as integral from 0 to 5. And of course, you don't have to compute all that by hand. As soon as you get this integral from 0 to 5 of r of t with respect to t, type that into Wolfram Alpha, let it compute it for you, get the number immediately, and you're done. And again, that part is just 1 point out of 6 total. What I'm mostly interested in is explanations. And let's look at the explanations overall. One line of introduction of the function, introduction of parameter with the limits, description of linear case, of the simplest case that you will use later. Subdivide. All this is going to be standard for integration setup. Then exact formula, exact summation. And that is going to be one of the two crucial cases, two crucial steps in the setup process. I will come back to it later. And then approximation of each of those summands. Claim that the limit is equal to the unknown value and, well, to the total change, and then computation.
Or equal signs, like just really equal signs. Can we just do equal for both in the computer, or do we need to be like?
Oh, for those, use equal for both.
Okay.
Or make it something like equal, so that it's not equal but almost equal. And I know that you know the difference. Yeah. Good question. Good question. In general, if you have to explain something in one test multiple times, I would like to see it only once. If you have to, well, if you'd like to show me that you know how to compute dot product, you show me in the first problem, and you don't show me anymore, I will trust you know that. If the problem has multiple parts, and those parts are repeating, show it once, and then tell me that the other steps are similar, just repeating. If you have two integration problems, then those most probably will be so different that there is no way you say that, well, this is similar to what I just explained in the other problem. The advantage of computer for you is that you can copy all this, paste into the second problem, and change the details, right? Because now you notice that something like subdivision into short parts is going to be repeating, linear case is going to be repeating, not totally, but to some extent, right? So yes, if you have multiple, well, if you have two or more integration problems, you're welcome to copy, paste, and change. If you have one problem, like one of the homework problems is that I'm about to discuss about displacement and distance traveled. There are two questions in one problem, and those require different integrals. You may want to put two versions for each step. Explain, say, for displacement, and then some in parentheses or just next to it. In case of distance traveled, this step is like that. Just emphasize the difference, but use the same parts. All right, good questions. Keep asking. No more?